all over 2a. Nice. Okay, what the heck does that do? Any idea? Remember what it does? Yes?
You can find the solution even if it's non-factorable.
All right, so why would this have not been a great time to use it? Why would this have not been a great time to use it? Yes?
Because you can easily factor it.
You could have easily factored it and it would be way easier. And I always say if you can factor it, you should. So what if that, though, had been like a plus 13? Do you get how it wouldn't factor then? That'd be a good time to use it. But would you agree that since it is easily factorable, we could find the answers for this in like a few seconds? And therefore, I'm going to leave that problem that way and see if you know how to use the quadratic formula with those numbers. And use the quadratic formula, you'll get the answer, and then you can check it really easy because I can do this in my head and go, oh, I know the answers of this and this. So go ahead, use this formula and stick in the numbers that you know in for A, B, and C to find x. I'm trying to find x equals, and you should know A, B, and C in this formula here. If you don't know what's going on, ask the kid next to you, but you'll be able to easily check yourself because this one factors. All right, so just to make sure you're getting off on the right foot, negative b would be negative of negative 4. Okay, take it over from there and get the answers both ways. Do it with factoring, get the answers that way, and then do it with quadratic formula, get the answer that way. I'm going to pause for a sec while you try that. Okay, so I'm hoping you knew that this was a 1 right there. And then this was a negative 4, and this was a negative 5. And those are A, and B, and C. And so when you put them in, you would have had negative of negative 4 makes 4, plus or minus the square root of b squared, which is 16, minus 4 times A, which is 1, times C, which is negative 5, all over 2A, which is 2 times 1, which is 2. Do you see why that's on the top 20? It is, because you have to know how to simplify those things down. I just happen to make it work so there's usually a square root left over. In this case, I think this works out nicely. Otherwise, then, you know, we wouldn't get a nice whole number of answers. So it probably does work out nicely. All right, and it's 16 minus negative. Notice that makes it plus. 16 plus 20, which makes 36. And that worked out nice. 4 plus and minus the square root of 36, because that's really just 6. So then it's 4 plus and minus 6 all over 2. And then that could be simplified to 4 plus 6 over 2 and 4 minus 6 over 2. And then you have 10 over 2 and negative 2 over 2. And then it's 5 and negative 1. And the way you could have checked that is from factoring the other one. The other way we could have done it is factoring this, and we would have factored it by going x and x, and then how am I going to make a negative 5? Oh, with a negative 5 and a positive 1, and look at that. That actually works. I get negative 4x in the middle when I check my work here. And you might feel like, wow, you're taking a lot of time to just say what that answer is. See all those steps? So I'm going to remind you that steps are really important. Showing work is really important. On the AP test that you guys will eventually take for AP Calc, if there had been an AP test for this class, it'd be the same thing. They don't just give you a point for the answer. They'll give you, a typical scenario is that there's 9 points and only one of them is for the answer. Literally. So let's say there's a super smart kid and he just goes, answers are 5 and negative 1. They get 1 out of 9. Serious. So it'd be like, okay, if kid gets this far, we give him 1 point. Kid gets that far, we give him 2 points. Kid gets that far, he gets 3 points. Kid gets that far, 4 or 5 points. Gets this far, 6, 7 points. 8 points. And then the 9th point, in this case, I told you to check it against the factored answers. There's the 9th point. You see how a kid that just has the answer actually hurts themselves? the kid that shows more work gets more credit. And that's what I'm going to practice with you today, because I'm giving you 2 questions. And you are going to try to show all the work you could possibly show, because the more work you show, the more points you get. The point is not to get to the answer super quick and write it down. You're going to get like 1 point. Another kid might get 10 points because they showed more work than you. And you're not used to that, but that's what we got to get used to, because that's where the AP tests are. Okay? It's not just because we're mean teachers that, we're going to force you to show work. We want you to get good scores in the AP tests, because if you do, then you get to test out of college classes, which is pretty nice. Think about it. An entire semester of calculus that you don't have to take because you passed the AP test. There's a reason that those are worth pursuing, because it saves you a ton of time in college. Maybe you can take basket weaving instead, and that's something you really wanted to learn how to do. Or maybe you could do like my daughter really wanted to do, which was to take she had a way she could get her master's degree and her bachelor's degree done in 5 years. That's not normal. Normally it takes you like 7 years to do that. But she wanted to get in really hard classes, so she tested out of a whole bunch of the easy ones. So my point, AP tests are coming for you, not this year for you, but probably next year. Some of you guys are you guys taking AP classes other than this? Raise your hand if you are taking an AP class. All right, so there's a bunch of you that are going to see this in other areas. Each of the APs is different, but I would bet that they have a similar thing where the point isn't just to get the answer as quick as you can on the tests. If they're multiple choice, well, duh, yes. They just want you to circle the right one. But on the free response part, it's not just about get the answer as fast as you can. All right. So we're going to pause for a minute in the middle of the lesson for today, and I'm going to give you this 10-step challenge. Now, I want you to work with somebody, and I'm going to assign you that person, and I'm going to have you slide your desks next to each other, and you can and should encourage each other, like, can we show more work here? Is there a way? Now, you can't just copy the same step over and over and over. That doesn't help, right? It has to make a change from the last step to this step. But the small changes are better because you'll have more work shown and therefore get more points. Now, just because it's called the 10-step challenge does not mean that every problem can have 10 steps. Okay? It means throughout the entire quiz, you're going to get points for trying to get close to 10 steps total that you showed of work. Okay? And yes, the answer will be worth a point, but the answers won't be worth more than 1 point. The work will be all the other points. Okay, so it's out of 10 points, and there's only 2 questions. So if you only have the right answers for those 2 things, you're going to get 2 out of 10. It's about showing the work. Okay, so I'm going to pause for a second while we do that. All right, so we have taken that little practice quiz about showing your work. We will grade that in a bit, but right now it is time to move on. So I'm talking a little bit here about the tennis ball lab. That is a lab where we are going to go outside with tennis balls. You're going to throw it up in the air. And the only thing we have to do is time how long from the second it leaves your hand until it hits the ground. So how are we going to time that perfectly? It's really hard to actually click a timer to start at the second you let go and stop at the second you land. You'll be off for sure. So what we do is we record it with the iPad. So somebody records you throwing the ball up in the air. And the key thing they have to get is they have to get it in the shot where you let it go from your hand, because you can like slow it down and see that's the exact second that you let it go. And then they have to also be able to get where the ball landed. So the camera person has to make sure to follow that ball enough to see where it lands. Okay, so where it leaves your hand and where it lands. And then they can see exactly how long the ball was in the air. Okay, so that's the only difficult part of this whole thing, is to get a good data. Once you get good data and you know that the ball was in the air for 2.3 seconds, which would be actually a really long time. It's hard to keep that ball in the air much longer than a second. But do you get that we can use the quadratic formula for something here? Let's think about this. So here's why this lab fits in here, because at this moment is the moment that the ball left your hand, because this is time across the bottom. You get time as the independent variable and always goes on the bottom. Did you know that? If you didn't know that, time is the ultimate independent thing. You've probably heard Time stops for no one. Okay, so time is independent. It doesn't care about whatever else is being measured against. It's just ruthlessly goes on. All right, this would be the height of the ball, not how far away it is from you. Sometimes kids get this confused that that's how far away the ball was when it landed. No. At each of these moments, it's how high is the ball now and after how much time. Do you get that a vertex is a really important thing? All right, there's a way to get the vertex for how high the ball went for any quadratic, and this is the part where you should be taking notes if you aren't already, because this, I'm telling you really good stuff about the lab right now. This thing at the top here, that's the vertex, and if you didn't know, x is negative b. Does this sound familiar? X equals negative b. But then we skip a few things and it's all over to a. Do you get that that's the beginning and the end of the quadratic formula? That is the x of the vertex. Negative b over 2a is the x of the vertex. Well, what's the y of the vertex? It's whatever you get when you stick that f in. So it's f of that. And I'm not going to say f of x because we know what x is. What's x again? Negative b over 2a. That's how you get the vertex. X is negative b over 2a. That is one of the most forgotten formulas because it's part of the quadratic formula. So I'm going to do this quadratic formula again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And I want to remind you, this right here, that part of it is the part that tells you the x of the vertex. The vertex is the most important part of a parabola. And you might feel like I'm, singling the parabola, out to be, or the vertex out to be like super special. Well, it is, because it's the spot where it changes direction. There's only one of those. Every other spot is not the very top, okay, when the parabola is upside down. And of course, when the parabola is right side up, there's only one really low spot. So that spot is important. So this part gives you the vertex. All right, so let's actually do that for the one that we had a minute ago. I gave you an equation, and it was x squared minus 4x minus 5, I think.
Yep.
Would you please figure out the vertex of that? I just told you it would be negative b over 2a for the x of it. Did you just figure out that that was negative of negative 4 over 2a, which is 2 times 1, which is 2? Do you get that that's really 4 over 2, which is really 2? Okay, 2 comma what? Technically, it's f of negative b over 2a, which means you basically stick that back in the function. So since this turned out to be 2, gentlemen, stop talking. Since that started off as a 2, I'm going to stick the 2 back in the equation now. 2 goes here, 2 goes here, and now I have 4 minus 8, which is negative 4, minus 5, which is negative 9. Okay, I'm feeling something's off here. Oh! Well, this wasn't an upside down parabola. This was a right side up parabola. And so its y-intercept was negative 5. So if I were to graph this parabola, it would make me feel better about this because it's touching right here at negative 5. And it's a right side up parabola. So 2 negative 9 means that this parabola was going down like that. This was not a suitable parabola to do for a ball thrown up in the parking lot. This one's going down, so maybe this is like a submarine going down and then coming back up. All right? Do you get how I got the 2 negative 9? It was the vertex. I got it by doing negative b over 2a and then taking that number, which was 2, and sticking it in the function. And then that gave me the negative 9 by sticking the negative 2 right here. Sorry, the 2 right there. You with me? Okay. Now, A little more I need to teach you about the quadratic formula. There's a lot built into that there formula. X equals negative b plus or minus square root of, now I'm going to change colors here, b squared minus 4ac, and then I'm going to make it all go back to red, all over 2a. Does anybody remember the name of that part of the quadratic formula? You do?
I always forget which it is. It's either the determinant or the discriminant.
It's the discriminant. Discriminating minds remember that it's the discriminant. That is called the discriminant. D-I-S-C is good enough. Okay? Discriminant. So what that does, you tell me, if that part, I'm going to highlight it now just to make really sure you get, I'm only talking about this part, not the square root of it, just the blue part, just the stuff under the root. If that was ever negative, do you get you don't have real answers? Because you have a square root of a negative. It's true. Okay, so you won't have real solutions if that's ever negative. That means we can tell from the discriminant, we usually abbreviate it D. If the D is less than 0, you have no solutions. If the D is greater than 0, you have how many solutions? 2. 2 solutions. Why? Because if this is greater than 0, if let's say it's like, I don't know, 6, or let's make it a perfect number square, like 4. If that was 4, then I'd have the square root of 4, which is 2, and then I'd have to do plus the 2 and minus the 2. Because of that plus minus in front, if you ever get a D that's bigger than 0, you'll get 2 solutions. So then what do you get if the D is equal to 0? If this is really 0 in here, do you get that it's just gone? Then do you still have a solution? Yeah. And it's this red part. And what's the red part again? We just said it seconds ago. What's that part? That's the vertex. So if you have a 0 here, this will disappear, and you will have one solution, and it's the vertex. One solution, vertex. I just taught you probably 4 of the questions on your next test. Were you paying attention? If your mind was drifting, I pity you, and I'm going to remind you again. If you didn't take good notes on this, take good notes now. Discriminant less than 0, that's this part here that I scribbled out, that part in there. If that's less than 0, you have no solutions. If it's bigger than 0, you have 2 solutions. If it's equal to 0, you have 1 solution, and that 1 solution is the vertex. Okay, so if I give you an equation now, x squared minus 6x plus 7, I did it nice so it would factor, but you're not going to factor it. You're just going to tell me what's its discriminant. Well, first of all, what is the little formula for discriminant? Mira? Starts with B. Nope. You're thinking of the vertex, I think. What do you think it is?
E squared minus 4ac.
Yep, that's the discriminant. And now we'll figure out what it is, and then we'll see if it's positive, we're going to have 2 answers. If it's negative, we aren't going to have any real answers. And if it's 0, we'll get 1 answer, and that 1 answer will be the vertex. Okay, so you tell me, does this thing have 1, 2, or no solutions? Well, I'm going to put in B is negative 6. Minus 4 times A is 1 times C is 7. And then I get 36 minus 28. And what is that? 8? Oh, I think you might be right. Can you guys verify the discriminant is 8? So that means there's 8 solutions, right? No. Well, how many solutions? 2. And if you think about it, we could have gotten them really easy in this case. X and plus and minus, and then, well, the negative team's going to win, so I'm going to make that negative 7, and this is positive 1. Do you get how that factored to that? No?
It'd be x minus 1.
Dang. Oh, you're right. There's, okay, my bad. This does not factor to that, Mr. Server. Quickly erasing. Erasing again with a stronger eraser. Okay, good. Does this one factor even? I'd have to put two negatives, and then it's going to be positive 7, which is good, but then it's going to be negative 8. This one didn't factor, but I still can know that if it's a parabola that's got a y-intercept of 7, so it's like way up here. My gut says that it doesn't have any real solutions, that it should be a negative, but maybe I'm wrong. Maybe it does have two solutions. This says it has two solutions, so I'm going to trust that. The discriminant tells me that there's a positive, so there's two solutions. Well, what are those solutions then? Watch how fast this is. Do you get that x equals negative b plus or minus this? Oh, wait a minute. We already have the discriminant. You know what I mean? It was square root of 8. We already did the discriminant. Why do it again? All over 2a. Okay, then I just have to go stick in for my equation. B was negative 6, so negative of negative 6 makes positive 6. And then all over 2a, which is 2 times 1, which is 2. There is two answers. It's those two. They're weird little decimal answers, but there's two of them. Does that make sense? Oh, it can be simplified. You are correct, and that is right off the top 20. This one could be root 4 and root 2, which is 2 root 2, and then it'd be 6 plus or minus 2 root 2 all over 2, and then absolutely, Cappy, you notice that because this is right off the top 20. The 2 factors out of the top, and then I have 3 plus and minus root 2 all over the 2, and then the 2's cancel, so it's 3 plus root 2 and 3 minus root 2. Cool. Okay. What did you learn about the quadratic formula today? Well, I hope you learned that it's got the vertex formula buried in it at the beginning. And that's right here. That's the x of the vertex, and that's all you need. Once you know the x of the vertex, you can just stick it back in the formula to find the y. And this part tells you how many solutions you're going to get. All right. So what if I wanted to force this thing, some equation that I have, I wanted to pick A so that this thing would for sure have two solutions. Then what you're saying, Mr. Server, is that you want b squared minus 4ac to come out and have two solutions. So how do what does that do to have two solutions? It has to be bigger than 0, and then it'll have two solutions. Would you agree that this is a quadratic? I should really say equals 0. And then would you agree that I don't know what A is, and now you might be like, but A is normally in the front. They could pick any letter, and they sometimes do on the ACT just to mess with you. They pick this to be A, even though you were expecting A to be up here. They can pick any letter they want, and they put it here. Okay, so we're saying A in this formula is not really A. It's supposed to be the B spot. And you guys are too early at this to really get what I'm saying, so maybe I should just make this B. But they can label it anything they want. But I'm going to change it to a B now because I'm afraid too many people will be confused. All right, so if I leave that as B, which is what you'd expect it to be, maybe it'd be a more reasonable compromise to make it like Q or some other letter that isn't in the formula. Now, I know that I want this to be bigger than 0, and what is B? Well, B is B. That way, again, my life is easier. I can just call it B. Minus 4 times the A is 1 times the C is negative 2, and that needs to stay greater than 0. Do you get you can solve that now? It's just got one thing left. It's B. So it's B squared plus 8 is greater than 0. B squared is greater than 8. Negative 8, thank you. And then I told you this is going to come up at least 3 times this year. Square root. And wait a minute, I just had to square root a negative. What does that mean? There must not be an answer for this. So what does that mean? There's no way to make this equation that we started with right here, there's no way to make that thing have two real roots. Yes. Did you find a mistake in there?
Where it has a b squared or a squared plus 8, b squared plus 8 is
Yep.
greater than 0.
Yep.
Then b squared is greater than -8. All squares are positive, so then
They're all
would it be?
Oh, instead of no reals, it's all reals. I think that's what you're saying, right?
Yes.
Okay, yeah, that really got confusing. Let's talk about that for a second. You were right here. Was I right to square root both sides? Well, kind of, or sorry, yeah, square root both sides, kind of. Like, that's how you solve b squared. But she's saying, and she's right, that b squared is greater than -8. When is that greater than -8? When is something squared greater than our negative? Always. Yes. I'm going to have to actually, it's rare that I have to write something like that down, but I got to write that one down because I am not knowing why why I can't square both sides on this one and make it work. I mean, I agree, you are right. This is always true, but when I square root it,
I think we had like a problem like this once, and then,
we can't, yeah, sorry, we can't keep going on that riff because I don't know what problem you're talking about once a long time ago. All right, so we have to get on to the new stuff for today. So that is the new stuff for today, but I want to flip through the notes quick. So don't forget the lab is coming where you throw the ball up in the parking lot. And again, the key there is you're going to know the moment you release the ball. Please don't talk right now. And that's here because time is 0 at that moment. And then that's the height of the ball. This is height. Do you get that that's how far above the ground you were? Now, we aren't going to be able to go out there and measure you exactly on where your ball is being released. That's really hard to do. So I'm going to pick a standard height that pretty much everybody is going to be releasing the ball over their head. Okay? And most of you are in the neighborhood of releasing that ball at about 2 meters. I get you're going to be a smidge less than that, but believe me, it's so much easier to have a nice clean number there. That height above your head is going to be 2 meters. Then the ball goes up some amount, depends on how strong you are, and the ball comes back down again. What's that moment when the ball hits the ground? What formula gives you the x-intercept? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's what gives you the x-intercept. This other one we took a moment and reminded you was something comma something for the vertex, right? What was the x of the vertex? -b over 2a. And this is good notes on the lab. If you're not taking them, you're lost. And f of -b over 2a. Okay, so there's what I was trying to get across to you, and this part there is the discriminant, and this part of the quadratic is the vertex. I should actually include the x equals. And this is the discrim. And the discriminant has those deals where if it's less than 0, you're square rooting a negative, which is no solution. And if it's bigger than 0, it'll have 2 answers. And if it's equal to 0, the discriminant just wipes out, and all you're left with is the vertex. One solution, and it's the vertex. All right. You need any more time to write this down? Okay. Then, what if they have a quadratic in an absolute value? Well, first thing, my rule holds up. If you can factor it, you should. Can you factor that? Yes, you can. And why does it matter? Well, first of all, I'd like to know what that parabola is, I'm dealing with the inside of it here, and if I know what it factors to, then I'm going to know its x-intercepts. I'm going to be able to draw it so much better. Would you agree that this is negative 3 and plus 2? Raise your hand if you already knew that. Cool. Then that's negative 3. No, wait. Positive 3 and negative 2. And my parabola is right side up. How do I know? Well, it's got an absolute value around. It's going to have to be. But this is where my parabola would have been. And what would its vertex have been? Negative b over 2a. You could have figured that out. This spot right here would be negative b over 2a, comma, whatever you get when you stick that in the function. F of that. So you could have figured that out, and I believe it would have been at 1 comma something. Yes?
Would the vertex be positive because it's negative 1?
I'm just trying to figure out what's going to be exactly between these two. And don't you feel like that would end up being a positive number? Because it's further to the right. I'm pretty sure it would be positive. It might be positive a half or positive 1 or something like that. All right, but we can figure it out with negative b over 2a. All right, we're going to stop like obsessing about exactly what this looks like because it's absolute value of it. And if the absolute values are on there, around the outside, on our last test, you guys learned that meant the bottom flips up. Do you get that red graph is basically what the answer looks like? And if you really, really, really needed exact points, wouldn't you just use your best friend in graphing, the XY chart? You can just stick in 0 and see what you get. Stick 0 into this, and you'd get negative 6, but the absolute value of that is 6, 0 comma 6. If you just really want the graph, it's easy. Just find a bunch of dots and connect the dots. And you'd find that it was looking like this because we know how when you absolute value on the outside, the things that were negative flip up. All right, and this had a lot of deep stuff in it. Okay, so do you get that this would not be good for using the quadratic formula? Why not? Because it isn't multiplied all out. Yeah, I got to get it all multiplied out before you'd know what A, B, and C are. But it's really good at telling you the vertex. Do you guys remember that? What's the vertex on this one? What comma what? 5 comma 13. So I know where the vertex is. I know it's upside down. And that's all I really need to be able to make a graph of this thing. It looks like that. Because I know the vertex and I know it's upside down. And now if I wanted the domain and range, the domain will be easy because I can see it's an upside down parabola and it's all therefore all reals. The range would be from negative infinity until what's the highest it ever went? 13. And the vertex came from the vertex. Right there. But it wasn't negative 513. Notice we don't trust the inside. All right, it's starting to stack up where if you didn't know basic facts about math, then there's probably 5 things you didn't know in here because you forgot the quadratic formula. You didn't remember that it was negative b over 2a for the vertex. You might not have remembered the thing called the discriminant, but I've reminded you of all these things. And now you got to be able to know all of the things I just told you on your next test. Like how to find this vertex. How do we do it again? Well, this was in vertex form, so it was easy. How could we have done it? Negative b over 2a. If I multiplied that whole thing out, which would be a pain in the butt, but you could do it. Okay. So this is completing the square. Holy cow, there's a lot of new material in here, but we have to do it. But I did teach it to you before, thankfully. Do you remember it? Do you remember me saying we go x squared plus 8x, and then we move the 1 over here and leave some room, and then we do half n squared? What's half of 8? 4. What's 4 squared? And if I plus 16, I have to immediately minus 16. Now notice this 1 that I moved over was a plus 1. And it's just the same number moved over. And those 2 new ones, the blue and the black one, those would cancel each other out. But why did I put them there? Because that part factors. And if you can factor it, you should. X plus 4 quantity squared. And then minus 15. And why is this awesome? Because now I know the vertex. Do you get that that's a lot faster way to get the vertex than the whole negative b over 2a thing? It is. That's pretty fast. And I now know my vertex is -4, -15. And that's pretty fast. Unfortunately, it's not quite that easy. I see a cell phone. Put it away now so I don't have to single you out. There's one more thing we have to step up in pre-calc, of course. All right, so this 2 messes everything up. Not saying everything, but I can't do my complete the square thing with a 2 there. So this is going to blow some minds. That 2 can be factored out of just the beginning part. You have never, I don't think, factored out something from just the beginning part, and then we're not, on purpose, factoring out everything that we could. We could have factored out a 2x, but we don't. We just factor the 2 out. And then I'm going to put my +3, but I'm leaving room again at the end. Do you get what just happened? That right there got factored, and the 2 came out of it. All right. I'm starting to look at the time and going, okay, I can't complete this for you right now. We don't have time. And so we're going to, it's not like it doesn't exist, but we need to learn that tomorrow, not today. All right. So your homework for today you did on that paper. That was to test on last night's homework. Your new homework, I strongly recommend you practice because today was pretty dense. Here's where the homework actually starts. And I encourage you to do this one. I'm going to keep it small. And this one. And this one. Just 3 questions. If you do that tonight, you'll be way happier when the test rolls around than if you didn't. All right? I'll teach you that more complicated complete the square later. You're going to hand me that homework quiz that you took in class at the door as you leave. And that's all I got for the video for today.